So in the last video we talked about the composite data type called a list. So here we're going to talk about a second type of composite data structure that's called a tuple or tuple, depending upon your preference of pronunciation. It could be pronounced differently. I've seen both kinds of pronunciations actually. So now let's talk about the tuple. Right. The tuple is just like a list, except that it is immutable. Immutable means that once the tuple is created, its content cannot be modified. So how do we actually define a tuple? Defining a tuple. How do we actually define a tuple? To define a tuple, all we have to do is to change the square brackets to parentheses. It's very similar to a list, except that now we are not using the square brackets. Now we are using the parentheses, right? And inside of this parentheses, we can put into any number of elements we would like, and we can also mix the type. We can also mix the different data types inside one tuple, and all the elements must be separated using a comma. And this comma is very, very important, right? If you are missing the comma, it's not going to work. It's not going to work correctly. So once we run this script, it's going to create name T1. The type is tuple, and the size is 4 because it has 4 elements in it. 3 strings and 1 float. And for tuple, this parenthesis is actually optional. If we remove the parenthesis, the result is still the same. If we just do this without the parenthesis, and if we run it, it's going to create an identical another tuple with identical content. So the parenthesis is actually optional. But the comma cannot be omitted. You cannot sort of not including the comma. The comma cannot be omitted. They are mandatory. They are mandatory for separating the elements inside the tuple. So in fact, if we have a tuple with just a single element, suppose we have a tuple with a single element, T3 equals to, right? We still need a comma behind this single element. Hands on start, right? We still need a comma behind it. So T3 is a tuple with the size of 1. It has just 1 element in it, right? This comma must be there. If we do not include a comma, we're going to get something that's entirely different. Entirely different, right? So suppose we do not include the comma, but we include the parentheses. Then what's going to happen, right? Then what's going to happen? Then we get a string. So T4 is actually a string with the content hands on start, right? So if we add the parentheses, it will still be a string, not a tuple. Unless we put a comma behind the element inside of the parentheses. So if we do T5 equals to hands on start. If we do that, if we do this, then T5 is going to be a tuple. So that's how you actually define a tuple, right? Then how do we actually access the elements, right? How do we access elements? How do we access elements inside of a tuple? The method for accessing the elements of a tuple is identical to that for accessing the elements of a list. So if we want to print the first and the last elements of the tuple, we can just use the index 0 and -1. So this will actually print the first element inside of the tuple T1, and this will print the last element. So the first element is hands-on start, and the last element is a float 1.0. But if we try to actually modify the content of a tuple's element, so suppose we try to change the version number from 1.0 to 2.0 for the last element inside of a tuple, right? Then we're going to get an error message. So it's saying tuple object does not support item assignment. It's actually a very clear error message. It's telling you cannot modify the content of a tuple's element. For a list, we don't have this kind of problem, right? A list is mutable, but for a tuple is immutable. You cannot change its content. So this line of code is actually incorrect. It's an incorrect code. It's a wrong code. So we cannot actually put a tuple's element on the left-hand side of an assignment. In fact, we cannot append, insert, pop, or remove any elements from the tuple because the tuple is immutable. But if the tuple has a mutable element inside of it, so here we define a tuple with a list as its only element. So T6 equals to, it's a tuple, right? It's a tuple, but its only element is a list, and a list is mutable, right? So this mutable element of the tuple can still be changed. For example, we can actually insert a new element into this list. So we can do that by T6 0, we retrieve the list, right? And then we can call the insert method. So before we actually run this code, let's look at what T6 actually is, right? So T6 tuple 1, 3, right? Now let's run this line of code. Let's see what's going to happen. So T6 tuple 1, now the list becomes 1, 2, 3, right? So if the tuple itself is immutable, but if the tuple has a mutable element, that mutable element is still mutable. You can still actually change that mutable element, right? Suppose we make one more change, right? Suppose we want to change this list, the first element of this list, right? How do we actually access the first element of this list? By using the square bracket 0, right? We want to change it from, for now it has a value of 1, right? Suppose we change it to 5. Then what's going to happen? Right, now the first element has been changed to 5, right? So if the tuple has mutable elements, you can change that mutable elements. But if we really want to change the tuple itself, there's one way to do that. We can actually first convert the tuple into something that's mutable. For example, a list, right? So suppose we can create a new list L1 by using the list function, and then inside the list function we give it an input that's T1. So T1 itself is immutable, right? But now we are using the list function to convert the immutable tuple into a mutable list that's called L1. So L1 is going to be a list with a size of 4, and L1 is actually mutable. So now we can actually change the last element of L1 into like 2.0, right? And then we convert this list back into the tuple by using the tuple function. So now if we look at what's going to happen to the tuple T1? It's going to change to, the last element is going to change to 2.0 instead of 1.0 now. It's 2.0 now. During this kind of a conversion process, we must know that this entire process is actually equivalent to creating a new tuple and then assigning this old variable name T1 to this new tuple, this newly created tuple. The original tuple that's created here, the original tuple, it is still immutable. It is not modified in any way, right? The whole thing on the right hand side, it's not modified in any way. But now there is no variable name associated with this original tuple anymore, because the old name T1 is no longer pointing to this particular tuple. It's pointing to this newly created tuple. Right? This old tuple is just staying there. There's no reference pointing to it. Right? At some point, it may be garbage collected. Right? And the Python string is actually very much like a tuple of characters. It is also immutable. All its methods, such as lower, upper, and title, do not change the string itself. Right? So T4 is actually a string, right? T4 is a string. It has a type of string, right? So let's define new string from T4.upper. So this kind of methods is going to return a new string. So S1 is a new string. The original string is still unmodified. So T4 is still there. It's not changed in any way. Right? So the string itself in Python is actually immutable. We can try to print. So S1 6, the sixth element inside of the newly created string S1. The sixth element is 0, 1, 2, 3, 4, 5, 6. It's an O. It's a capital O, right? If we print it, we're gonna see the capital O here, right? But if we try to modify, this particular individual character inside the string, suppose we want to change it to little case or small case O, right? Then Python is going to complain. str object does not support item assignment, right? So this experiment is telling us the string is actually immutable. It's just like a tuple. It's immutable, right? And there are consequences. There are consequences of this immutability. There are advantages also, right? So Python string is immutable. And what are the utilities of a tuple, right? Why do you want to use a tuple which is actually immutable? You cannot change it. What's the purpose of doing that? One of the utilities is called tuple packing and a sequence unpacking. So basically a tuple is a convenient way to pack together a set of different values. So here T1, this thing here, and then later recreated, not recreated, created here, sort of assigned to a new tuple here, right? This tuple is actually some kind of is a packing. It's actually represents this one name, actually one variable name actually represents 3 strings and 1 float. Right? So these 3 strings and 1 float are all packed together in just one tuple, and then that one tuple can be represented by just one name, T1. Right? And at some stage, we need to assign those values inside the tuple T1 to 4 individual variables, say. Then we can use the assignment operator in a way that's that might surprise you. S2, S3, S4, f1 equals to t1. Right? It's a kind of, if you are used to other kinds of languages, you may find it confusing, right? On the left-hand side, you have like 4 different variables that's kind of separated by comma. So the left-hand side is something that's called a sequence. Both list and tuple are actually subclasses of the so-called sequence class, right? And then on the right-hand side, it's actually a tuple. So basically, but this tuple actually has 4 elements in it. So it is important to make sure that the number of variables, the number of variable names on the left-hand side is exactly the same as the number of elements inside the tuple on the right-hand side. Right? So if we run it, now we have like a S2, S3, S4. S2, S3, S4, all of them are strings. And then F1 is a float. F1 is a float. So all the individual elements inside of the tuple are assigned to those 4 different variables. 3 of them are strings, and the last one is a float. And it's actually a one-to-one correspondence. It's an exact mapping, actually. And so if the number of variables on the left-hand side is too few or too many, we will get error messages. So suppose we have just as S3, S4, F1 equals to T1. Then we're going to get an error message. Right? Too many values to unpack expected 3. Right? So this line of code is incorrect. We have to comment out this line. And if we have too many S2, S3, S4, say F1, then X equals to T1, then it's also going to complain. Right? Not enough values to unpack. Expected 5, not 4. So this line of code is also incorrect. So tuple packing and sequence unpacking is sort of one utilities for tuples. And also in your big code, in your large Python code, you can use tuples to store some kind of a system-wide or sort of your software-wide sort of configuration variables, that kind of thing, right? Because it's never going to change during the entire application. So the tuples can be used for that kind of purpose. Now let's talk about a third composite data structure, the set. The set. The set is actually an unordered collection of elements with no duplications. So how do we actually define a set? Right. So to define this a set, we can use a pair of curly braces. So suppose countries equals to, we're going to define a set of countries. We're going to use a pair of curly braces. Even though I'm writing down all the different countries in this particular specific order, but its internal representation of this particular set doesn't really give it any kind of ordering. So the ordering of those 4 items or 4 elements inside of the countries set is undetermined. It could be anything. Depends upon your machine or depends upon the time you are running the code. So, and all the elements still must be separated by this comma. We still must separate them using a comma. If we forget to use a comma, suppose we do countries 1, the result is going to be unexpected. It's something that's it's probably something that you don't really want. So suppose we get rid of the comma, even though we keep the spaces, right? So let's run it. So countries is a set with like 4 different elements in it. But countries 1 is a set with just 1 element in it. And this 1 element is actually a concatenation of all the strings. Right. And you can sort of see for the countries, this particular set, the ordering, Canada, India, Mexico, and the USA, that's being printed here, is actually different from the ordering of the 4 strings I typed in, right? So the ordering inside of the set is undetermined. We can also mix data types in a set, right? So let's do countries 2. So now, but now there's no association. There's no association between the string and the number because all the elements are not ordered. There's no any kind of association between the country name and this particular number, which we used to represent the population in millions, right? So let's run it again. So we get countries 1, countries 2. Right? So the ordering is like unspecified, undetermined. So there's no association whatsoever. So to create an empty set, so these are sets that with sort of elements in it. But if we want to create an empty set, suppose we want to create an empty set of states, can we actually do that? Can we do that? Can we do that? Let's run it. Let's run it. We are getting a states, right? But the type is not a set. Here the type is set, right? But here states has a type of dict. It's actually a dictionary. It's not a set. It's a different data type. So this empty curly braces is actually reserved for creating an empty dictionary instead of an empty set, right? So this line of code, it's correct, but it's not what you intended, right? So we have to be careful about this kind of empty. It's this kind of empty sets. So to create an empty set, what's actually the correct code, right? So set states 1 equals to, we have to use the set function with empty input, and states 1 is going to be a set. So states 1 is actually a set, right? And it's supposed to have nothing in it, right? So this set function can also be used to convert other data structures, such as a list, into a set. So if we do states 2 set, right? But suppose we have we give it a list. Colorado, Alaska, Florida. Suppose we give it California again. I was telling you that a set is supposed to be unique, only contain unique elements, right? Let's run it again. So states 2 is a set Alaska, California, Colorado, Florida. This duplicate California has been removed, right? We have 2 California in the same set. But a set cannot contain duplicates. So all the duplicates has been removed. Right? And that's state 2, right? By using the set function instead of typing in the content of the set or typing in all the elements of the set. And we can also use a tuple as the input to the set function. So if we don't want to use a list, we can also use a tuple. So I'm just going to copy and paste over the code. Right. So states 3 is supposed to be identical to states 2. Right? They are actually identical. So now if I change the list to a tuple by changing the square bracket to a parenthesis, then let's see if it's still identical. Yes, right, it's still identical. So you can use either a tuple or a list as the input to the set function. Right? But suppose we give the set function a string, letters set California, right? So we are giving it a string. Let's create letters 1, set Colorado, right? Then what's gonna happen? What's gonna be the stuff that's inside of the letters? And letters 1. So letters is gonna be a set with all the characters inside of that string listed. And you can sort of see that all the duplicates of the characters or the letters has been removed. For example, in California, A appears twice, I appears twice, right? But now we have just one character A and one letter I, right? All the duplicates has been removed. For letters 1, it's Colorado, right? Colorado, you have like 3 O's, but in the set you have only 1 O, right? So if you give the set function a string, then it's going to convert it into unique set of letters, a set of unique letters, right? And all the duplicate characters will be removed. And in order to actually add new elements into an existing set, we can use the add method on the set. So states 1 is an empty set, right? There's nothing in it. So states 1, it's an empty set. It doesn't have anything in it. But suppose we want to add a string. We add a string to it, right? And then let's run it and let's see what's going to happen. Now states 1 has one element, Alabama, inside of it, right? And another way of adding new elements into an existing set is to use the update method. And then the update method is not going to take an element, it's going to take a set as input. So states 1.update. The update method is going to take a set as its input. So Alaska, right? Arkansas, and let's do Alabama again, right? So for now, Alabama is already in states 1, right? Here we're actually updating the states 1 with a new set, right? But this update is gonna remove the duplicate update Alabama. And if we actually remove Alabama, let's do a reset. And then rerun this code. Then what's gonna be states 1? Right? States 1. So states 1. It's we started with an empty set, right? And then we added Alabama, right? And then we updated with a set of two additional states, Alaska and Arkansas. And now what's actually inside of states 1? It's Alabama, Alaska, Arkansas, all 3 states, with all 3 states, right? So that's what update actually is, right? The update is not gonna overwrite. It's not gonna overwrite existing elements inside of the set. It's gonna add new or additional elements to the existing set. And if there are any kind of duplications in the input of the update, it's going to remove those duplications. If we would like to access individual elements inside of a list, it's kind of very easy, right? We just use the index into it. But if we would like to access individual elements inside of a set, there is no easy way of doing that, because the elements inside a set are unordered, so we cannot actually use an index. Right? We cannot really actually use an index. So if we do print countries 0, then what's going to happen, right? So countries is a set. It's got like 4 countries in it, and here we are actually printing countries 0. So it's a set object that does not support indexing, so you cannot really use an index into a set. You cannot index into a set, right? So this is actually incorrect code. You cannot do that, right? You cannot do that. If we do have to access individual elements inside of a set, we must convert the set into a data structure that supports indexing, such as a list. So if we do print list, we use the list function to convert countries into a list, then we can index into it, right? So now it's printing Mexico, right? It's not reporting any error, but it's printing Mexico, right? But here you can sort of see the ordering is Canada, India, Mexico, and USA, but printing the 0th element, the first element, it's actually giving you Mexico. So the ordering is still kind of undetermined, right? So this line will work, right? But it may give you different results on different machines, or at different times of running, because the ordering in the set is undetermined. So the ordering of the elements inside of this list that's created from this set is also undetermined, right? So what are the utilities of a set? What are the utilities of the set? What can we use the set for, right? The set is actually useful in a variety of situations. It's actually a very useful thing. If you are a Java programmer, you know that the Java collections also provides this set data structure, right? Because every element inside of a set must be unique. So a set can be used to eliminate duplications. So here is a numeric string with 9 numbers inside of it. So do a list. Right. So we're actually converting this this string of numbers into a list. So L2 is going to be a list of those sequence of strings, basically, right? Every number is a number, right? But it's actually inside of the symbol code, so it's actually treated as a string, right? So here, using the list function, I'm converting a string into its individual characters, basically, right? But a set created from the same string is going to have no duplicates, right? So L2 is going to have duplicates. 4 is a duplicate. 7 is a 7. 5 is a duplicate, right? So, but if I do S5 equals to set, the same sequence of strings, then it's going to remove all the duplicates, right? S5, where's my S5? S5 is here. 0, 2, 4, 5, 7, 9. No duplicates, right? All the duplicates characters or the numbers has been removed, right? And we can also use a list, use a set for something that's called a membership testing. Membership testing is what? Is to test if an element is inside of a collection or not. So print so this in, it's a keyword. The keyword in is actually an operator in Python, right? And this operator is gonna return true if the thing that's in front of it is inside of this particular data structure, is inside of this particular collection. And it's going to return false if this element is not inside of this particular collection, right? So let's see, if 0 is inside of S5, right, it's going to return true. It's going to return true, right? And let's see if 3, the number 3 is inside of S5, right? And it's going to return false. It's going to return false. And the set data structure is actually particularly efficient for doing this kind of a membership testing, right? Because it has no duplicates. So So it's a very short, right? And the set also supports various mathematical operations. If you are a mathematician, you know how to actually do mathematical calculations on sets, right? And Python also knows that. Python also knows how to do calculations, mathematical calculations on sets. So here we have two sets of letters, right? One is called letters, right, which has this sequence of characters inside of it, right? And then we have another set that's called letters 1, right? These are two sets. So one mathematical calculation is called the union, right? So let's try to create letters 2. How do we actually do union for two sets, right? Letters and then vertical bar, letters 1. So letters 2 is going to be a set of characters. Letters 2 is going to be a new set, right? And the letters inside of letter 2 are going to be the letters that are either in letters, this particular set, or in letters 1. Right? If we run it, we have a new set called letters 2. And this new set is going to contain all the characters that's inside of letters and all the characters that's inside of letters 1, with all the duplicates removed, actually, right? This vertical bar means all. In computer language, it's called it means all, right? And in mathematical calculation, it's gonna do a union of the two sets. So that's called the union, right? That's called the union. And then we can also compute the intersection of two sets by using the ampersand. The intersection is actually the subset of characters that's in letters and also in letters 1. So that subset of letters must exist in both sets. So letters 3 is going to be the set of letters that in both letters and letters 1. So CALOR, right? That's called intersection, right? And it's carried out by using this ampersand. And then we can also compute subtractions of two sets. Letters 4 is going to equal to letters subtract letters 1. And this is going to be what? Let's look at the results. Right? Let's look at the result. So letters 4 is going to be a set has FIN in it. So what exactly is this kind of an operation in mathematics, right? So it's going to create a set of characters that are in letters, but not in letters 1, right? Elements in letters, but not in letters 1, right? If you actually put letters 1 first and letters later, right? If you use letters 1, subtract the letters, then this subtraction is going to print out, is going to create a set with elements that's in letters 1 but not in letters, right? So that's what subtraction actually means for the mathematical meaning of a subtraction between sets, right? So FIN, it's a FIN. So FIN is inside of letters. So FIN, that's inside of letters, but it's not inside of letters 1. Right, so you don't see F here, you don't see I here, you don't see N here. So that's what subtraction between two sets actually means. And then the last one that we're going to look at is called exclusive OR, which is computed by using this angular hat. This is called exclusive OR. And let's see what this thing is gonna create, right? Letters 5, that's DFIN. So what exactly is exclusive OR, right? It's gonna create a set of characters that either in letters, this particular set, or in letters 1, but not in both, right? It's gonna pick all the characters that's either in this one, in this set, or in this set, right? But not in both sets, right? That's called exclusive OR, right? So for mathematicians, these kind of set calculations are built into Python, and it's actually implemented very efficiently. Now let's talk about the fourth composite data structure, which is called dictionary. It's called dictionary in Python, but it may have other names in other languages, and sometimes it's called map or associative array or symbol table in other languages, right? And in algorithms or data structure classes, you may have heard of those different names. They pretty much mean the same thing. And in Python, it is called a dictionary, right? In a list or tuple, the indexes of all the elements are always some kind of integers within a certain range. And in this case, we say that the key of any element value is an integer. So indexes, so tuples or lists can also be considered as some kind of a map, right? It maps the key integers to particular values, right? But in certain applications, we would actually prefer to use data types other than integers as the key to a certain value, right? We don't want to use the integer as the key. We want to use some other data type, for example, a string, a tuple, or some other kind of a very complicated data structure as a key, right? And in Python, the dictionary data structure is the right choice for such applications. So how do we actually define a dictionary, right? Defining a dictionary. So to define a dictionary, you can use, again, the curly braces, and then with the key value pairs separated by comma. So suppose we want to define a dictionary that's called country underscore population, and then we're using curly brackets, right? The curly braces, when we are using sets, when we are defining sets, these kind of curly braces are just enclosing elements separated by comma, right? But now what's going to be our elements, right? Our elements are going to be key value pairs that's separated by a colon. Right, so each of the item or each of the element inside of the dictionary, they are still separated by a comma, right? But inside of a key value pair, inside of one element of a dictionary, right? That's one key value pair. The key and the value, are actually separated by a colon. So you use a colon to separate the key from the value inside of a key value pair, right? And we have already mentioned it. We have already mentioned it when we were talking about sets, right? So this empty pair of curly braces is going to create a empty dictionary, right? It's not going to create an empty set. An empty set must be created using a set function, right? So country population is going to have a type of dict. It's got two key value pairs inside of it. Canada 36, USA 321, right? And then country population 1 is also a dict, right? It's a type of dict, and then it's got nothing in it. So it's got a size of 0, right? We can add key value pairs to an existing dictionary in a syntax that's kind of very similar to assigning values to an element of a list, except that the index now is given by the key instead of integer. So it's probably better if I just copy over the variable name instead of typing it. Right. So now we have to use the square bracket to index into a dictionary. Right. But the key that we are going to use is not going to be integers like 0 or -1, that kind of thing. Right. It's going to be actually the key. Right. So country population 1, for now it's an empty thing. It's an empty dictionary, right? But if we actually execute this line, then it's going to have one key value here inside of it, USA colon 321, right? And we can keep adding things to it. So suppose now we add Canada 36. Right, now it's got like 2 different key value pairs inside of it. Right. There are some restrictions about the data type that can be used for the key. In Python, the data type that can be used for the key of a dictionary must be an immutable data type. So strings or tuples are fine. But if we try to actually use a list as a key, we're going to get an error message. Suppose we want to sort of define a dictionary that's called a population country. Right. Suppose we use a list as a key. And the country name, the string as the value. So sort of the opposite, right? Sort of the opposite. Now it's going to give us an error message, right? It's telling you unhashable type list. So this is actually incorrect code. This is wrong. This is wrong, right? But if we actually change the list to tuples, it's going to be fine actually. So if we actually change this line of code, we change the square brackets. We change the square brackets. Change the square brackets to parentheses. If it's just a single parenthesis, that's not going to work, right? Because you have to put the comma behind it to actually make it into a tuple, right? If we do that, then it's not going to complain, right? It's not going to complain. And the population country, we're supposed to have a dictionary called a population country. It's a dictionary with two elements inside of it, right? And the keys are given by the tuples, right? So tuples itself is actually immutable, right? But if the tuple actually contains a mutable data type as its element, right? So if we actually change it into something that contains a list, right? So now the tuple is not just integers anymore. It's actually an integer with the list as its element, right? Now we're gonna see the same kind of an error message now. Unhashable type list. Right. So again, this line of code is incorrect. So your tuple cannot contain any kind of a mutable elements. Another way of defining a dictionary is to use the dict function, which takes a list of tuples as input. So here we're going to use the dict function as to construct a dictionary, right? And this dict function is going to take a list of tuples. That's one tuple, right? And then That's the second tuple, right? So country population 2. So country population 2 is supposed to have country population 2, that's a dict with 2 elements, Canada 36, USA 321, right? That's another way of constructing a dictionary, right? And the dict function also takes another dictionary as input, right? So suppose we create another dictionary that's called country population 3, and the dict function, the input of the dict function is going to be country population 2. Let's just copy it over, right? We're using country population 2 as the input to the dict. Let's run it again. And now we are having a country population 3, right? And it's going to have exactly the same content as country population 2. And this dict function is going to actually make a deep copy. It's going to make a deep copy of the input dictionary. So it's going to allocate a new memory space and copy every element inside of the country population 2 into that new memory space, and then assign country population 3 this name to that memory space. Right? So if I make a change to country population 3, for example, if I add a new key value pair for Mexico to country population 3, suppose I add a new if I add a new key value pair to country population 3. So for now, country population 3 is identical to country population 2, right? But suppose I add a new key value pair to country population 3. Then country population 3 is going to have a new key value pair, Mexico 127, right? But country population 2 is unchanged, right? So it means that the dict function is actually making a deep copy of country population 2, right? For large dictionaries, if the input dictionary is like a very large, then this deep copy will take a very long time to actually complete, and it's going to consume lots of memory spaces. So it's going to be, so we must use this kind of thing very carefully, right? Because it's going to make a deep copy. So for dictionary, how are we going to access the element, right? How are we going to access the elements of a dictionary, right? To access the values inside of a dictionary, we must use the corresponding keys. And so suppose we do a print, right? Country population USA, right? Then it's going to print out 321. Right? So it's just like accessing the values stored inside of a list or tuple, except that the key is not a integer anymore, right? But it's a key that's inside of the dictionary. So if we try to actually access a key that actually does not exist, so country population doesn't have a key value pair for Mexico, right? But suppose we try to access that particular key, that non-existent key, right? Then what's going to happen, right? Then it's going to complain, key error Mexico, right? So because Mexico doesn't actually exist in this particular dictionary, right? But on the other hand, if the non-existing key actually appears on the left-hand side of an assignment operator, suppose we do this thing. Suppose we do country population Mexico if we do this thing, right, it's still accessing a non-existent key, right? But it appears on the left-hand side of an assignment operator. And in this case, Python is going to understand it as trying to inserting a new key value pair into this particular dictionary. So it will treat it as inserting. It will treat it as inserting a new key value pair into the dictionary, right? Right. So this is gonna work. This is the correct code actually, but this is actually incorrect code, right? Here you are accessing a non-existent key, but here you are actually trying to inserting a new key value pair into the dictionary. Right? If the key appearing on the left-hand side of an assignment operator already exists inside of the dictionary, so suppose we're change the Mexico to Canada to 360, right? If we do that, Canada already exists, right? Canada already exists in the dictionary, right? It's a key that already exists. Then what's gonna happen, right? Then what's gonna happen, right? So let's just try it, right? Now Canada is the value associated with Canada, the key Canada, has changed from 36 to 360, right? So Python will use this new value. It's gonna use this new value 360 to actually overwrite the previous value, that's 36, right? So this kind of feature will actually ensure that it is impossible to have duplicate keys in a Python dictionary. So all the keys in a Python dictionary are going to be unique, because if you try to actually add a duplicate key by using this kind of the same key value, the same key into the dictionary, it's going to overwrite an existing key. It's not going to add a duplicate key. It's going to overwrite the value that's associated with an existing key, right? So this kind of feature is going to ensure it's impossible to have duplicate keys in a Python dictionary. To remove a specific key value pair from a dictionary, if we know the key, then we can just use the pop method on the dictionary. You can just use the pop method, right? And this pop method is going to take a key, right? For example, Canada. Then the return value, the value that's associated with this particular key are going to be stored, are going to be sort of returned for the output population, right? For now, country population, if we do the pop, it's going to remove Canada. So now there's no Canada inside of it. And we're going to have a new integer called population, right? Population, that's 360. That's used for storing the return value from that pop. So that's accessing individual elements inside of a dictionary, right? And in some situations, we would like to access, for example, all the key value pairs inside the dictionary, right? How do we actually access all the key value pairs? There's a method called items that's defined on the dictionary. So items equals to country population dot items, and then we can just print items. So now we are going to have a so here that's the printout from this print items, right? It's telling you that it's a dict items, and then with these elements inside of it. So each of the tuple is actually a key value pair, right? That's if you have more than 2 key value pairs, then this print is going to list all of them, right? And the return type for items is something that we haven't seen before. It's so the items is right here. That's the name of the variable, and the type is called a dict items, right? That's the type. So what exactly is the dict items, right? This data type is called a view. It's called a view in Python 3. In Python 2, the behavior is actually quite different. The items method returns a list of tuples that we can actually index into. So here is Python 2.7.10, right? Let's try to define the same. Country population. Let's just copy over this piece of code, right? So now we have a if we do a type country, that's a dict, right? And then if we call the items method on this particular dictionary, and then assign it to items, then the type of items is going to be a list. It's going to be a list. It's a list of tuples. If I want to index into them, I can just do that. So item 0 is going to return a tuple for me, right? And then if I want to retrieve the value 36, I can actually index into that tuple, right? So indexing is going to work, right? But in Python 3, the items is not a list. It's a type that's called a dict items. Right? So this dict items doesn't actually support indexing. If I try to index into items, then it's going to give me an error message. So it's telling me dict items object does not support indexing. So if I do that, it's not going to work. So this is actually incorrect code. This is actually incorrect code in Python 3. In Python 2, it's okay, but in Python 3, it's not going to work. So how do I actually index into a dict item, right? How do I actually index into a dict item? I have to sort of convert the dict item explicitly into a list by using the list function. And then the list function takes the items as input, the dict items as input, and then it's going to return a list. And this time I can actually index into it. Right, it's going to return USA to 321. Right, so this code actually works. So in Python 3, we have to do an explicit conversion of the output of the items method in order to actually sort of use the indexes. And the reason for returning a view instead of a list is in Python 3 is to actually save memory spaces. In order to return a list, Python actually has to actually make copies of all the information from the dictionary into the list and then return that list. But returning a view will not actually cost any additional memory. So there's no explicit copying of information or data from the dictionary out into a list. Right? A view is not going to cost any additional memory. And we may also want to sort of get all the keys and all the values separately, right? So this is actually getting all the key value pairs into like a one object, right? But sometimes we may want to sort of get the keys and get all the keys and all the values separately, right? If we want to do that, we can do keys values equal to country population dot. We have a method called keys, right? And a method called values. And this way, it's gonna get all the keys and then all the values. Again, the returned keys and returned values are still gonna be dict keys and dict items. So keys are gonna have a type that's called dict keys. And values, where's values? So values is gonna have a type that dict values. And both dict keys and dict values are subtypes of views, so they are still views. If you want to index into them, you still must actually explicitly convert them into a list by using the list function, right? So if I do a print keys, print values, it's going to tell me it's a dict keys USA Mexico, and then dict values 321 and 127, right? And the keys are not sorted in any way. So the keys are not sorted. If you want to sort them, if you want to get a list of sorted keys, you have to sort them explicitly. using either the sorted function. Let me see if that's going to work, actually. Yes, it looks like it's working. So all the keys is sorted. But if without the sorted function, it's going to be USA, Mexico, right? USA, Mexico. But now with sorting, you have actually Mexico, USA. And the sorted function actually returns the list, you see. So now you have no dict keys in front of it anymore. You have just a list that's been printed. Here you have dict keys. Again, this behavior is actually different from Python 2. So if in Python 2 I do keys, values equals to country populations dot keys, country population dot values. The return types of keys and values are going to be lists, are going to be a list, so you can actually index into them directly, right? Right. So that's one of the important differences between the behavior on Python 2 and the behavior on Python 3. Right. In Python 2, the same method calls are going to return lists, right, which consumes additional memory, but you can index into them. In Python 3, the same method calls are going to return views. You cannot, it's going to save memory, but you cannot index into them. If you want to index into them, you have to use a list to do an explicit conversion.